everyone! Welcome to episode number 552 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Yes, this week's podcast is all about multi-die systems. Shekhar Kapoor, Senior Director of Product Management at Synopsys, joins me to chat about the challenges a transition to multi-die systems is looking to solve, the role that EDA and developments in manufacturing will have on the mass adoption of multi-die systems, and the variety of benefits that multi-die systems will bring to applications like AI processing, big data, and more. So, without further ado, please welcome Shekhar to Fish Fry. Hi, Shekhar. Thank you so much for joining me.
Thank you. Glad to be here.
So let's talk about the transition to multi-die systems. So first, Shekhar, can you set the stage for us? What challenges is this transition looking to solve?
Many. Thank you, Amelia, for the question. So the transition, or I would say the need for transition to multi-die systems is being necessitated by a sort of perfect storm of challenges which have been emerging for quite some time now. I'll break it down into 3 or 4 different constituents of this perfect storm. First, which is the obvious one, is the technology scaling. A lot has been talked about the Moore's law. And as you know, that this whole insistent demand for greater functionality, for more performance, to really enable all these data-driven lives that we live in right now. This means packing more and more compute power into all kinds of devices around us. We're already moving from nanometer era to the angstrom era, but the transistor density scaling and the power and performance benefits going from one node to another have been kind of diminishing. And we're seeing actually marked slowing down of the scalability advantage in some of the newer nodes. So this really means that you cannot continue to move to newer nodes and expect to cram as much as you can into the single monolithic SoCs and expect to get the same ROI. So that's been the much talked about, but the main driver. And related to that is, of course, is you're running up against fundamental radical limits, which is manufacturing related. Radical limits is the maximum die size that we can image. And this places kind of an upper bound on the amount of integratable functionality that you can put in the chips. And that's the kind of, limits the two-dimensional growth. And third, very important related challenge is cost. If you pack as much as possible into these radical bound dies and push the sizes to the limits, we then face with the issue of poor yields, the number of known good dies that you can get out of the wafer. And fourth, which is actually a significant driver in some of the specific applications, is around this bandwidth limitations and the I/O density. So getting all of that data in and out of the SoCs. You can think of it, all these data pipes that need to run between traditional PCB board connected SoCs or I/O for memory to hold all of the data that some of these advanced transformer models for AI require. So anytime we have to move the data in and out, there's a turnaround time cost, and it's becoming increasingly prohibitive in terms of power consumption as well. Ideally, you want to move all of this data processing and data storage as close as possible. But in a 2D world, as your die sizes continue to grow, it's not possible. Things move further away, and then you have bandwidth and latency issues. So you can see there are kind of, many issues which are coming together and then forming these kind of a perfect storm and stressing and limiting the innovation, which we have been used to for the last many decades. And that kind of, is really leading to something new, the need for something new, something more evolutionary, and that's where the multi-die transformation is happening.
That makes sense. Now, Shekhar, a mass adoption to multi-die systems needs to be facilitated by EDA and developments in manufacturing, right? Can you address those two elements as well?
Absolutely. So you're right. I mean, these are the critical enablers, the advances in EDA and actually IP and also manufacturing going hand in hand together. EDA advances are actually fueled all these productivity gains, these new waves for the last many decades. And in that sense, multi-die is not new. That's another wave that EDA and IP is bringing in. And actually, if you look at the history of multi-die systems, that's also not entirely new. There are many niche applications which have been developing these 2.5D systems or, in some cases, selective 3D systems for over a decade now. And we have been working with those customers, providing the ED and the IP solutions to ensure that, they get the productivity and the efficiency as much as possible, even if the reference flows and the methodologies of today did not exist at the time. But as, of course, more and more people jump on the multi-die bandwagon, it's critical that you take all that learnings, all these knowledge that you have gained when doing these early stages of the multi-die design and bring them and scale them. The whole idea is that, can you transition the world from 2D to the multi-die 2.5D, 3D in a very seamless and efficient way as possible? So at Synopsys, this is the question that we've been long focused on, that how do we make the customers continue to scale and how successfully we can enable them to transition from the system on chip to system off chips or chiplets-based design. So again, if you look at, when you going through this transition, many things are still the same, that, your requirements from which were there in the 2D point of view, but at the same time, many are changing as well, and some are new entirely. Potentially, when you look at multi-die design, what you're dealing with is the integration of the functionality that could manifest itself in tens or even hundreds of individual dies. And how that functionality is apportioned is of critical importance. How you configure them to get the maximum PPA advantage out of it, that's the critical thing. So in some of the designs, in some cases, you could be using the designer IP from the previous projects, the whole reuse concept, and connect them with the other dies on an interposer or through stacking, the so-called bottom-up approach. Or in some cases, you're completely doing a fresh idea that needs to be imagined and architected in a top-down fashion. So what you really need is to support both these bottom-up or top-down methodologies for the design teams that are getting into the multi-die world. And additionally, what happens is that the complexity of dealing with all these many dies into the system now means that, you have to not only look at them in an individual way, you have to look at them all together and co-design, co-optimize all these dies and along the package that are going to be encompassed in, which means you got to look at design, verification, test, integration, all the sign-off methodologies all together, which if you boil it down to, you need a very holistic interconnected solution and a comprehensive end-to-end solution from architectural design all the way to the sign-off and the manufacturing technologies. So there are many pieces to it, but at Synopsys, what we have is a kind of a full solution all the way from silicon to system design, if I may. It starts right at the top. Architecture decision becomes very important, when you're thinking about building these complex systems. How do you split, what's the hardware, what's the software, and how do you verify it all together? So you need, we've been investing in technologies like platform architects and system verification and validation solutions like ZeBu emulation, continuing to advance the capacities of it, the throughput, the speed of these solutions, to really help you build that very early on, architect that system that you're seeking in terms of your specification. And then the big question is going from those feasibility analysis to crystallizing into something which is more physical in nature. And that's the implementation world. The challenges I mentioned is to really going seamlessly from 2D design to 3D design, building on the flows and the infrastructures which are already there. And that's where, we have industry's only integrated platform, 3D IC compiler, which allows you to kind of visualize, build, and co-optimize this entire 2D to multi-die 3D system all in one place, and then handle all this billion scale challenges which is emerging. Again, going back to it, I said a couple of times that the systems could be tens of dies, and which means like hundreds of millions of connections and billions of transistors. So you've got to bring it all together into one system. And then also embed the analysis engines in it, which is where, the key challenge that is emerging is some of the third order effects or second order effects have become the first order effects from an analysis point of view. You hear a lot about power, thermal, signal integrity. Again, the whole idea is embed them all into your design platform. And that's what we've done. We brought in Synopsys technologies as well as our partner Ansys technologies, made them all available to help you analyze throughout the flow and optimize the system in the context of all of these analysis and the KPIs. There are many other things that, manufacturing reliability is becoming a big concern. The challenge with a single die itself is big, making sure that, the quality of each of these dies is maintained, is achieved. But when you put them, all of them together, it becomes in an amalgamated kind of system that it becomes even bigger problem. So you need to have the quality, reliability, and repairability available for such systems, which is, I would say, an expanded requirement for multi-die systems. And that's where we have invested heavily into solutions like silicon lifecycle management, which allow you to optimize from all the way from design to in-field operation and provide better reliability for the systems. I know it's a long answer, but one critical piece that I would like to mention is that the heart of all of these is the IP. System that we're talking about is a disaggregated or a heterogeneously integrated system which has many dies. But all these pieces need to communicate and be connected and interface together. That's where the die-to-die IP comes into the picture. So besides basically the full stack of EDA solution from architecture to reliability, investing in IP is critical. And that's what, we've been building a most comprehensive IP portfolio in the industry. Chances of, if you ever needed an IP at a desired process technology and all to meet the spec, we will have it available, enable you to integrate such systems together. In that context, of course, I would mention that this UCIe, the die-to-die IP Universal Chiplet Interconnect Express, has gained a lot of excitement and a lot of traction in the industry. And we are working closely with the consortium and also with the lead customers to advance that interface. So as you can see, the many pieces, going back to what I said in the beginning of the answer, that EDA and IP have always driven and enabled many of these waves in the industry. And the same is replaying. We're doing the same and in a holistic way for the multi-die systems.
Okay, so Shekhar, applications like big data, hyperscalers, and AI processing can be a great fit for multi-die systems. So can you talk about the benefits that the multi-die era could bring to these industries in particular?
Yes, so actually I touched on it earlier when I was talking about the transition and what are some of the drivers. But you're right on the mark. I mean, these are very relevant applications where we're seeing a lot of momentum for multi-die. All of these markets and these applications actually have hugely common requirements. One is they're all dealing with very vast and fast increasing amounts of data. And second, they all crave for efficient processing and easier access to this vast data. So you're dealing with large amount of data, and then you want it to be very efficiently processed. By way of example, the hot topic of the moment is all these large language models or the transformer models like the Chat GPT. That kind of intersects all of these areas you mentioned for big data, hyperscalers, and obviously AI processing. So these large AI models have essentially greatly reset expectations and the requirements. Going back to Moore's law, if you see what Moore's law has basically delivered around a 2x improvement in the processing every 2 years or so. That was a given. But AI, from its earlier beginnings in AlexNet, which was for vision processing, to the very new, these transformer or large language models like ChatGPT-4, these require about 800x improvements every 2 years in processing power. So that's significantly higher than what Moore's law, for example, ever delivered. And more than that, these models themselves are built around, they have almost like 500 billion to 1 trillion parameters, which requires essentially a lot of memory. So now, where are we today? So the current data center architectures, the way they are, aren't efficient enough to bring these Chat GPT-like smartness to every user and device as we would like, because they're too expensive in terms of the hardware, the operations, and cooling costs. So don't get me wrong. I mean, they're serving. I mean, we're all using Chat GPTs and all that, but behind the scene, there are inefficiencies and significant costs. These are essentially massive farms of XCPUs, which are CPUs and GPUs and TPUs and a mix of those. And they're underutilized in the sense that, the movement of the data movement inefficiencies are huge. They are relying on this large amount of data accessibility and proximity, but that's not there. So what we're seeing is some of these leaders in the industry and Synopsys customers, we're seeing a lot of innovation that is driving this now in hyperscaler data centers and all that applications. Key part of the innovation is to bring about these massive collections of heterogeneous domain-specific processors, these CPUs, GPUs, together with their own data processing plane, like the DPUs, and then tightly couple them with high-density memories like the HBMs, and then basically essentially tying them all together in a single package so that you can address the latency and the power, and you can minimize some of these challenges that you have currently. So it essentially boils down to having a highly bespoke AI-tuned data center in a single package. That's the direction that we are seeing. That's the emphasis that some of these big players are putting on. And actually, if we go even further, this is not just about big data, hyperscalers, and data centers. Even playing out in this mobile space where we want to enable all these on-device, the large language model inference right on your smartphones. And then, of course, add all these process-tuned analog functionality like modems and audio, visual, and all this interactive technology to improve the user experience. And again, combine them all into a single form factor, smaller constrained package in this case. So LLMs and all play and drive the multi-die system in the traditional, one would imagine, this data center world, but even in the mobile, is this happening? And last piece I will add to that is even beyond these large language models, let's not forget the area of fully autonomous driving. A huge development is happening in this whole software-driven vehicle world. That the whole paradigm is developing on its own, which itself is demanding kind of supercomputer level of processing. And others, we want to kind of have these racks of computers in our entire trunk and the back seat. We want to be able to do it much more efficiently in much more compact way, and while achieving all the performance and the power requirements. And this is again automotive software-driven vehicles, all those ADAS enablement. That's another area where we're seeing the multi-die systems playing a huge role. So overall, I mean, multi-die systems are ushering in many benefits, which span many verticals. Yes, at the top of the heap, I mean, the ones which are really driving it, of course, are the data centers, hyperscalers, and AI applications. But closely following are the automotive and mobile as well. So overall, a lot of benefits that across the verticals that we are seeing.
So, Synopsys recently did a multi-die system industry insight report. So, Shekhar, what kind of information or insights did you guys learn from this report?
If you see, I mean, what we're talking about, if you look at the evidence by our own discussion, we've been seeing that, there's been a massive thirst for this information and insights on multi-die landscape, how is it evolving, the benefits, the challenges. And that was the reason that, we thought, why not speak to the real experts and innovators in the industry who are actually dealing in firsthand. So in that sense, we polled and received contributions from some of the most influential companies and leaders in the industry across the spectrum. In this case, namely Ansys, Bosch, Google, Intel, Samsung, and Synopsys. So a key comment that I recall from that inside report was that around the whole SysMore era, which multi-die systems have ushered in, and its acknowledgement, of course, that is definitely upon us. But what's important was the wide-ranging collaboration that is required to fully realizing the promise that we are all hoping and anticipating from this. And essentially that, the need to do more and more together. Related to that, one area that was echoed by all the companies almost was the need for industry-wide standardization. UCIe standard that I mentioned was one example that was touched upon, and the need of the hour is to continue to kind of have similar interoperability and standardizations across the industry that we need to work on. So in general, the companies recognize that there are challenges, but also that the opportunities, the benefits ahead are vast. And that will allow us to create many advanced products that consumers have never seen before, but can be used to make their lives more productive and safer. There's also agreement that advance this heterogeneous integration of dies or chiplets in a single package, which is the basic concept of multi-die system, will bring in new innovations to deliver such advanced products. So to summarize, overall takeaway was that there's a unique opportunity that multi-die systems offers us. and there's a need for collaboration, very tight collaboration to realize this promise.
Okay, so in particular from Synopsys, what are you guys working on when it comes to multi-die systems?
Many initiatives, Amelia. So, well, if you look at, given that we're still at the beginning of in the initial part of this industry's journey on multi-die system, there are many initiatives being worked on. I'll talk about two or three of them, which are kind of closer to a strong focus for us. And these are around ecosystem, of course, that whole collaboration part, this whole new area of system technology co-optimization, and then how pervasive AI goes hand in hand with that. These are huge opportunities and huge focus. And then, of course, Synopsys has been taking leadership position in all of these. Let's start with the ecosystem first. So as I mentioned, even in the inside report, there's a whole need for collaboration together. And we have a very large, vibrant ecosystem. On the supply side, you have IP providers, tools, foundries, this OSATs, the outsourced semiconductor assembly and test, and equipment providers, and more. So Synopsys, we've been deeply engaged and expanding our collaboration and partnership across the industry and sort of what we call the catalyzing the whole adoption through these partnerships. There are three sub areas, I would say, that under this ecosystem collaborations are kind of basically includes the development of these crucial pathways to enable the adoption. This is partnership to integrate the best-in-class technologies. Basically, we have some of the best-in-class solutions out in the industry, but we're also partnering with others in the industry like Ansys and Keysight to add that to the portfolio for customers' benefit. So that's one example of how we are collaborating. Second is promoting the interoperability standards. And then also going beyond and investing in more research, working with the universities and other research consortiums. In terms of the interoperability, we've been, of course, working closely with the foundries and the other IP players. And the result of that collaboration, one good example of the result of the collaboration is what we achieved with TSMC. TSMC is a 3D blocks format to describe the multi-die design, and also Synopsys' own multi-die exchange format for rules for 3D heterogeneous integration, how that has come along working with the partners and enabling, boosting the design activity. So besides the ecosystem, the second key initiative I want to touch on is pushing this whole new concept of advancement of the system technology co-optimization. Now, design technology co-optimization, or the DTCO, has long been used, and that has been a particular specialty for Synopsys. It has been used really in pursuit of extracting as much PPA entitlement as possible from each process technology. With the advent of these multi-die systems, we can now have a system comprising of many different process technologies. Each die or chiplet could be targeting a different functionality at a different functionality optimized process. So if we just try to look at these pieces in isolation, we are missing an opportunity to have an optimal system. So what you really need to look at it, again, which I said earlier, you need to look at them in a holistic way so that you can co-optimize all these pieces in the context of the full system. The focus, therefore, is to really think and design more completely, consider the entire system from the software stack that will be hosted on the eventual hardware, right the way down to the many possible silicon technologies that could be deployed to meet the specification. So Synopsys is unique in the industry that we have a complete EDA stack that runs the whole gamut of system technology optimization scope. As Synopsys tagline says, we bring the whole party together from silicon through to software. So we have been delivering many pieces of the solution in terms of methodologies and capabilities, from architecture pathfinding to manufacturing, to accelerate this whole convergence to optimized system. That forms the core of the whole STCO paradigm. But also in that context, when we talk about optimizations, comes up the third key initiative that I refer to, which is a pervasive AI. In 2D space, we've already seen the exciting deployment of AI technology to deliver this new levels of productivity and innovation. So if you have followed our recent announcement of this full stack, Synopsys.ai, which is leading the way by unleashing a whole new wave in the 2D SoC world. For multi-die systems and the STCO, we see deployment of the ML and AI-driven optimization technologies potentially unlocking even greater benefit, given the vast optimization space that we're dealing over here. So to summarize, there are many opportunities in front of us to enhance this multi-die systems. But the key initiative are along catalyzing the ecosystem to spur more adoption and also enabling this whole system to silicon system technology optimization, and then deploying the AI technologies to really speed up the optimization process.
Okay, so how about an off-the-cuff question, Shekhar? So, since you haven't been on my show before, here's your standard off-the-cuff. So, Shekhar, if you could have one meal right now, doesn't matter if it's on the other side of the world, you need a passport to get there, or the restaurant is closed, what would you have?
A very good question, Amelia. That makes me think. You said if I had the passport to go anywhere. When it comes to food, I have to say I'm quite nostalgic about my own hometown. I grew up in a place called Amritsar. It's a city in the northern state of Punjab in India. And it's a place renowned for its vibrant and rich street food culture. And amongst all these, the street foods, and one thing stands out. One which is my absolute favorite was this mouth-watering fried fish, typically sole or pomfret. And I'm smiling at the thought of, how coincidental this is, because I think the podcast is called Fish Fry.
It is. I love that.
Which is a perfect fit for someone like me. So since you said I could go anywhere, the flavors and the aroma of that crispy kind of, perfectly spiced fish with that hot chutney just makes me go back, anytime. There's some Indian restaurants out here, which serve that fish, and they call it actually the Amritsari fish, named after the city. But if you ever get a chance to visit Amritsar, please try it out. It's a culinary experience of its own. That's something I would just go back to in a heartbeat.
I love it. That sounds delicious. Well, it was a pleasure speaking with you, Shekhar. Thank you so much for joining me.
Thank you. Thanks for having me.
So, if you'd like more information about that multi-die system industry insight report Shekhar and I were talking about, or more information about Synopsys' multi-die system solution, I've included a couple links below the player on this week's Fish Frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter or X, sure, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, sure, I'd dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me. And of course, you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Frying page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of October 6th, 2023, I'm Amelia Dalton, and you've been fried.